Hello everyone, my name is Athar Chauhan. So today I'll be taking you through some fundamental concepts of machine learning, parametric versus non-parametric models, supervised and unsupervised learning, and the evaluation metrics that help us judge model performance. Don't worry, I'll keep everything simple, clear, and practical. To be precise, this is the fifth question of a series of end sem paper solution. So let's dig deep into it. Let's see what we'll cover today. So first, here's the roadmap of our session. First, we'll understand what parametric and non-parametric models are. Next, we'll explore supervised and unsupervised learning techniques. Then we'll look at the most important evaluation metrics like accuracy, precision, recall, and F1 score. And finally, we'll walk you through a confusion matrix and calculate these metrics step by step. So let's get started. First, parametric models. Parametric models are like fixed form equations. They assume a specific mathematical relationship between the input and the output. Examples include linear regression, logistic regression, naive Bayes. These models are fast, efficient, and work well with smaller data set. But the downside is they might oversimplify things and interfere when the patterns are complex. The non-parametric models. Non-parametric models, on the other hand, don't assume any fixed structure. Their complexity grows with the amount of data. Examples include k-nearest neighbors, decision trees, random forest, SVM, and RBF kernel. These models can capture complex patterns and non-linear relationships. However, they need a lot of more data, take longer to train, and can overfit if not regularized properly. Now let's discuss their comparison. Here's a quick comparison. Parametric models have a fixed number of parameters while non-parametric models grow with data. Parametric works well with small data set, non-parametric needs more data. Parametric models are simpler and faster. Non-parametric models are more flexible but slower. Parametric has lower risk of overfitting. Non-parametric has higher risk of overfitting. In simple terms, choose parametric for speed and interpretability. Choose non-parametric when you want to capture complex relationships. Now let's discuss about supervised learning. Supervised learning uses labeled data, meaning every input has a correct output attached to it. It's mainly used for classification tasks like spam detection or diagnosis, regression tasks like house price detection or demand forecasting. Common algorithms include logistic regression, random forest, SVM, and neural networks. Let's discuss about unsupervised learning. Unsupervised learning works without labels. The goal is to discover hidden patterns in the data. Examples include clustering, grouping similar data points together like customer segmentation. K-means in a is a classic example. Dimensionality reduction, reducing the number of features while retaining information. PCA or TSNE. And third is association rules, finding relationships between items like in market basket analysis using the a priori algorithm. It helps us understand data structure when no targets are defined. Let's talk about the evaluation metrics now. To judge how well a model performs, we need evaluation metrics. No single metric tells the full story, especially in classification tasks. We commonly use accuracy for overall correctness, precision for how correct our positive predictions are, recall for how many actual positives we were able to detect, F1 score, a balanced measure of precision and recall. These metrics become much clearer when we use a confusion matrix. Now, what is confusion matrix? Let's discuss with this an example. A sample of confusion matrix based on 100 predictions. Predicted positive, predicted negative, actual positive, actual negative. So the true positive is equal to 40, false negative equals to 10, false positive equals to 5, true negative equals to 45. Let's calculate all the key metrics using these data. For accuracy, the formula is TP plus TN. Just a second. Yeah. For accuracy, the formula is TP plus TN whole divided by total. So the calculation steps are 40 plus 45 whole divided by 100, which gives us 85%. This means the model accurately predicts 85% of the samples. So let's discuss with precision now. The formula of precision is TP whole upon TP plus FP, and calculation is 40 whole upon 40 plus 5, which is 88.9%. So when model predicts positive, it is right almost 89% of the time. Now the next metric is recall. Formula is TP whole upon TP plus Fn. Now calculation is 40 whole upon 40 plus 10, which is 40 upon 50, which gives us 80%. This means the model catches 80% of the actual positives. Now F1 score formula is 2 into precision into recall whole upon precision plus recall. Now after calculation, the result is 84.2%. The F1 score is balanced measure that considers both precision and recall, showing a strong overall performance. Going towards the final summary now. To summarize today's session, parametric models are simple, fast, and good for small datasets. No parametric models are flexible and capture complex patterns but need more data. Supervised learning uses labeled data. Unsupervised learning finds hidden structure. Accuracy, precision, recall, and F1 score each tells a different part of performance story. Thank you for listening.